SAT Skill Builder number 2. So these are going to be a little bit more complicated examples that are also using linear relationships. So our first item, it gives us a system of linear equations. We're told that we have C equals 4.15 plus 0.20x, and L equals 3.25 plus 0.50x. So we're told that C and L represent the price per pound in dollars of crab and lobster, respectively, X weeks after December 1st of last year. And we're asked, what is the price per pound of lobster when it was equal to the price per pound of crab? So the issue we have here is, first off, being able to decode the problem. If these are my two equations, it wants to know, what is the price per pound of lobster and crab equal? So the price per pound of crab is represented by this expression, price per pound of lobster represented by this expression. So when are they equal to each other? So we need to take these two expressions and set them equal. You can solve this exactly the way it is right now, but for a lot of us, dealing with decimals is something we'd rather not do. So if I take this entire equation, multiply it by 100, I'm going to move each decimal 2 places. So 4.15 plus 20x becomes 415 plus 20x, 325 plus 50x. Now we can solve. Variables on both sides, I picked the one that's less than to undo. Okay, trying to isolate the variable on this side. I'm going to remove the constant by subtracting it from both sides. (41 minus 32 is going to give me 90. So x equals 3. And remember, we're super happy because we have x equals a number, but we need to make sure we're answering the question that was asked. What was the price per pound of lobster when it was equal to the price per pound of crab? Well, we know that that happens when x is 3 months. So now we can go ahead and substitute this back into one of our original equations. Does not matter which one. Whichever one you think is easiest to work with. So 325 and $1.50 is going to give us 475. And so that is going to be our solution. Next problem involves slope. So these next two problems are going to require a little bit of critical thinking on the part of your students in order to go ahead and solve these. So I have an XY plane. I have a line that passes through the origin. So remember, y equals mx plus b. Its b value is 0. So I'm not even really going to worry about that. And I'm told it has a slope of 1/9. So y equals 1/9 times x is the equation of this line. Now I'm asked which of these points satisfies that equation. And the obvious one looks like 1 and 9. But if x is 1 and y is 9, that tells me that 9 equals 1/9, and that's not true. So that rules that one out. And you can repeat this process, substituting in values until you find one that works. So if I put in 27 for x, 1/9 of 27, 27 divided by 9 is 3, y is 3. So that tells me the point 27 and 3 is going to satisfy this equation. Another one coming up that's going to require some thought. We're given an equation. 9x plus 10 equals 20. And we are asked, if that's true, what is 18x plus 1 equal to? Okay, so in order to get a value for this, we need to know what x is. Here I have an equation that I can solve for x, so let's make that happen. So 9x equals 10, and x equals 10 over 9. So all of a sudden this becomes an increased degree of difficulty problem because I'm substituting in a fraction in place of this x. So let's make that happen. So now you're asking your students to be able to multiply a whole number times a fraction. A couple ways that you can approach this. You can multiply 18 times 10 and divide by 9 if you wish, but you may recognize that 18 and 9 have a common factor. 9 divided by 9 is 1. 18 divided by 9 is 2. So now I can multiply it. 2 times 10 is 20 plus 1. So the value of that second expression is 21 based off the value for x we got from that first equation. So a little bit more challenging problem. It took some skills that your students may not have used in a minute in order to be able to figure that one out. Let's take a look at one more that has a little bit of a degree of difficulty to it. All right, so this one really requires no calculation whatsoever, but it does require an understanding of what linear expressions mean and what the components of those expressions mean. So a roofing company estimates that the cost of installing solar panels for a home in dollars is represented by this expression, 75 plus 15 NT. So we have a set amount and a variable amount. This is definitely a linear expression. N is the number of roofers who'll be working. T is the total number of hours the job is going to take with N number of roofers. And it wants to know, what does this 15 represent? Okay. So recall that 15, that's our variable amount. That's the rate of change. That is our slope. What does the slope represent? So a change per whatever our variable is. So roofers 15 hours per day. Remember, we're talking about cost, not about hours. So that one doesn't make much sense. The price per job increases by $15 per hour. Let's come back to that one. Let's give it some thought. At minimum, 15 roofers will work on each job. Well, remember, N is the variable that stands for the number of roofers. That's being multiplied by 15. So we can rule that one out. And then the company charges $15 per hour for each worker. So if this is the total cost to the customer, we can kind of see what's going on here. When the roofer is costing out this job, he's got some number of roofers, each making an hourly wage, times the number of time that they all work. So 15 times the number of roofers times the time is going to be his total outlay for labor. So this looks a lot like each of those roofers is making $15 an hour. Let's go ahead and select that one. So this was definitely a situation where your students are being asked to think critically and to tear apart a problem that they cannot Google and they cannot stick into their calculator and just punch buttons and come up with a number. They need to have a deeper understanding of the concept of a linear expression and in particular slope-intercept form of a linear expression in order to be able to get this one squared away.